Hello everyone, today we're going to talk about the structure of the atom, what it consists of, and if you kind of open up the atom, let's see what's inside. So as you see in the screen, the atom is the smallest particle of an element, and there are currently about 118 different atoms that exist as you see on the periodic table. So an atom and the element, kind of the word is used interchangeably. And so if you have an atom, you are an element. Okay, so how small actually is an atom? So if you look at like the copper penny, a copper penny has about 29, that looks like about billion trillion atoms that make up the copper penny. But if you actually kind of break it up, kind of look a little bit deeper inside, so inside the copper you got like a layer of zinc. And if you keep going microscopically and microscopically, then you get to the actual one atom type of structure. Now, we never actually been able to see one atom before in any type of technology setting. We could see many atoms together. And what I mean by many atoms, I'm talking about like millions of atoms together. But we can't see one, okay? But we know this is what the structure of the atom looks like through many types of scientific experiments with Rutherford and J.J. Thomson, Moseley. So we know this is what the structure of an atom looks like. So if we kind of dive into it, there are pretty much two parts of an atom. You have the outer part, and you have obviously like the inner part. I've always liked to think that the atom is kind of like a peanut, or like an M&M, a peanut M&M. You got the inside layer, and then you got the outside layer. Or if you kind of think of it like a peanut M&M, you got the nut that's inside, and then you got like the chocolate layer, kind of like the kind of little gooey chocolate layer, and then you got the candy crush, or the candy shell to it. So inside you have a very tiny region, and we're going to talk about how tiny it is in just a second. So in that region, we call it the nucleus. And inside the nucleus, there are two particles that exist in there. And outside the nucleus is only one type of particle called electrons. And we like to call this region the electron clouds. There is no such thing as the clouds, because there's orbitals out there. But they've just always liked to call it the electron cloud. Okay, if you want to call it the electron, orbitals, that's fine too. But there's two main parts to an atom. So kind of the inside and the outside. So if you actually dive into this, there are three what's called subatomic, and the word sub means inside. So there are three particles inside the atom. So you got the atom, and then inside the atom. So inside the atom, we have protons, neutrons, and electrons. So inside the nucleus, you have two particles, as you see on here, the blue and the purple and the green. And then you have the electrons that are running at huge amounts of speeds all around the nucleus. So we like to call the three particles, protons, neutrons, electrons, the subatomic particles, because of the particles inside the atom. Okay, so let's dive a little bit deeper into each part. So the nucleus is a very tiny region, and this picture, as cute as it is definitely not to scale. Okay, the nucleus is definitely not that big compared to the whole structure of the atom. It's very tiny. Okay, and like I said, at the end we're going to talk about how tiny it is. So the nucleus accounts for most of the atom's mass. Inside here, these protons and neutrons, they have a lot of mass compared to the electron. And they have the majority of the mass of the whole overall entire part of the atom, okay? But it's a very little amount of volume, okay? And so when we look at how the electron versus nucleus compare, as you saw in the picture right here, okay, that nucleus is very tiny compared to the whole orbitals that are surrounding it with those electrons. So it's definitely a huge difference in size, okay? Because the nucleus accounts for most of the mass, it's very dense. And about 99.97% of an atom's mass comes from that nucleus. So inside the nucleus, we have protons and neutrons. And as you see right here for the symbol, protons and neutrons, they have a charge. and we have to put a symbol, a charge on those symbols. For a proton, we abbreviate it with a little p, and we put a positive on it because protons are positive. Now neutrons, they have a certain type of charge, but it's a neutral charge. So you still have to put a charge on that symbol. So for the neutron, we call it a little n, and we put a little 0, kind of like a little degree sign, a little 0 representing that it has no charge. Now the electron clouds obviously take up all the space of the atom. I mean, we're talking about the majority of an atom is completely empty space. But it's not what you think of like empty space, because there's electrons roaming through that empty space. So they have hardly any mass because they can move really fast. And because they're so light, they do have those like huge amounts of speed that they can move at. So the majority of an atom is empty space, but that's where the electrons are pretty much orbiting around the nucleus. And when I explain this to like little kids when they're first learning science, I think about, I always tell them like the nucleus is like the sun, and we and other planets, we orbit around that sun, and we all have a different pattern that we orbit around that sun, okay? And we know it's not circular pattern. It's actually more of like a kind of like an oval type of pattern. Now some planets more than others, but there are different types of rotation. So the majority of the space around the nucleus is completely empty space for those electrons to move around. So with electrons, they do have a negative charge, and we make the abbreviation for the electron like a little e with a little negative sign in the corner. You can put -1, negative, that's fine, okay, but they're always negative. And this is kind of a little summary about all three subatomic particles, okay? So the only two particles that actually have a charge are the protons and the electrons. Now there's two particles in the nucleus, and there's only one of them outside the nucleus, okay? So make sure when you are thinking about this, you're not thinking that the electrons are outside of the atom. They're not outside of the atom, they're in the atom, but they're outside of the nucleus, okay? So the only ones inside the nucleus are your protons and neutrons, and your electrons are on the outside of the nucleus, okay? As we already said, two of these have charges, -1 versus +1, and neutrons obviously mean neutral, so you have the 0 charge. Now these two last columns that you see, how much actual mass do they have? Well, I'm going to go to the last column first. So no, we have never been able to just take one proton and put it on a balance and weigh it, but calculation-wise, we know the approximate mass of all three of these particles. And the cool part about it is, remember we said the majority of the mass is the nucleus. And the nucleus, the protons and neutrons that are inside the nucleus, they have the same mass. Now you're looking at this number, 1.67 to the -24. That's a very, very tiny particle, and it should make sense because we can't even see them. They're super tiny, but they do have mass, okay? So the protons and neutrons, very tiny mass, but they do have the same mass. Now why don't you compare it to an electron though? So remember the electrons, taking up all that space outside the nucleus, but they can move really, really, really fast. So it should make sense they're lighter. And how much lighter are they? Well, you see 9.11 times 10 to the -28. Okay, well, let's just don't memorize numbers, but what does that mean? Compare it to the protons and the neutrons. The protons and the neutrons versus the electrons, you're talking about something that's 2,000 times smaller than a proton and a neutron. So when I mean by smaller, I mean in mass. It is smaller in mass, okay? So that's where you get this next to the last column. If I said the proton and neutron equal each other, so if I just call them both 1, well, the electron is 1 over about 1840. So we usually say about 1 over 2,000. So it's 2,000th the size of a proton and a neutron, okay? So it's not about memorizing numbers, okay? There's no point to that, but it's can you actually picture what an atom looks like? Where's the majority of the mass? Where's the majority of the volume, okay? In relations to which one weighs more or weighs less, okay? That's the point of what you need to try to understand with this chart, okay? So at the very end, pause it, try to answer the questions yourself, okay? And then unpause it to check your answers. So what are the two main regions of the atom? So the two main regions of the atom, there's only two. You have what's called inside the atom, called the nucleus, and outside the nucleus is your electron region, your electron cloud, okay? So you have two regions in the atom. Now, what's the charge of a nucleus? And I always love to ask this question to students because the very first answer I always will get is 0. And I said, I don't think you read the question correctly. Let's try it again. What's the charge of the nucleus? Well, then they say, well, 0 again. Okay, I said, well, let's kind of look at what this word nucleus means. And then it kind of hits them. I didn't say what's the charge of the atom, because you got to remember in your drawing right here, you have inside the nucleus, you have those protons that have that positive charge, and you have those neutrons that are neutral. Okay, but then you have these electrons roaming around the nucleus, and that positive is the only charge that's in that nucleus. So the charge of the nucleus is positive. Okay, but what's the charge of the whole overall atom? Well, positive and negative cancel each other out. As long as you have the same amount of protons and electrons, the whole atom, the charge is neutral. Okay, so be very careful about the wording of the question if they're talking about the whole atom or are they actually talking about the nucleus. Okay, hope this helped you, ladies and gentlemen, and we'll see you on the next one.